extreme value theorem. And I don't think it was in your notes yesterday. Okay. I mean, you dealt with it, but you really didn't deal with it. All right. And in calc, I usually do EVT. All right. We abbreviate it as this. Now, I'm not going to write out the formal calc definition, the one that we use in calculus or anything. I'm just going to talk about it a little bit. All right. To apply this extreme value theorem to a problem, we have to be on a closed interval. Okay. So anytime I give you a closed interval and then I ask for maxes and mins, all right, then you can kind of think, oh, hey, it's going to be this extreme value theorem. All right, it's going to help you find things. All right, so I'm going to have a closed interval. All right, and then basically what the theorem says is that our maxes and mins, I don't know if I want to write it this way or not. I'm trying to make this up off the top of my head. Her maxes and mins will, or I should say this. Let's not put the word maxes and mins there because I don't want to use the word maxes and mins twice. Let's change this. Let's change this. Yeah, whiteout's good unless you're in a hurry, and then it's not so good. All right, let's say extrema will occur at endpoints, or, and if I was in calculus, I would use the word critical points. All right, but you don't know that definition yet, but you do know maxes and mins. All right, so extrema, our maxes and mins are going to occur either like on the endpoints of this closed interval or on the inside where maxes and mins might occur. All right, so I'm just conceptual. We're trying to get a conceptual thing down here. I want you to conceptually get this idea. All right, let's say this is -4. Let's say this is 3. And then let's say I have a closed interval. So closed dot. All right, let's come down here. Let's go up here. Let's go up here. Woo. All right, now we got to label some of these points here. So I don't know. Let's say this is -2, -2. Let's say this is, I don't know. Let's say this point is 1, 3. This point would be -4, 4, -4, 4. This would be 3, 7. Okay. Now, I have a closed interval because that dot and that dot is closed. It is a continuous. This is a portion of a polynomial curve. All right. I'm just taking the portion of it. All right. If this went on, if I wasn't looking at just this closed interval, this polynomial curve would keep going and would keep going in those directions. But because I put those closed dots on there, I'm looking at just a section of this polynomial curve. It's polynomial because it's smooth and continuous. I was able to draw that whole thing without lifting my pencil. Ooh, I probably need to come up with this guy right here. Let's say that then that guy is, let's say he's 2, 2.5. Okay, almost missed him. Okay, now my extrema, all right, can only occur on the endpoints or on the interior. Those are the only points. That's our extreme value thing here. All right, now obviously we used the words global max and local max yesterday in the lecture or in what you watched video wise. All right, so global means what? The overall max of the entire thing that you're looking at. All right, now our book distinguished between where it's located and the value of it. Okay, so in other words, they're taking our pre-calc book is taking that ordered pair and separating it. Where is it located? Well, where left to right is it located? All right, and then what is the value of that max? Okay, so then that's your y. Now in calc, all right, we would just say that we have an absolute extrema. I'm going to abbreviate, and we would say our absolute extrema. We would say our max is at 3.7. All right, so this is what we would do in calc. Okay, we would say, what's our absolute extrema? Well, the max is 3.7 because in that interval, that's the maximum point that this portion of the graph reaches. All right, now in pre-calc, we would call this a global max. All right, and we would say it is located at x equals 3. And when we would say its value, the value of the max is 7. All right. I don't really like when our pre-calc book does this, but it's not a hard concept. You can master this. Where is it located at, left or right? And then what is that max? Okay. Now, so that would be, you only are going to have one global max. Okay. Now let's also make another note here for pre-calc. All right. Global maxes and mins can be at the end points and or inside. Okay, inside the interval. Relative, which was the other word, and I don't want to use relative because let's go global and local, because those are used more often. Local maxes and mins can only be, put quotes around that, inside the interval. Okay, so for pre-calc, I think that's going to help us a lot. I've used that explanation before and it has helped. Now let's go ahead and identify the global minimum. So in other words, overall, in that entire section right there, what's the lowest point it reaches? Well, we know it's here, right? So in calc, we would just say absolute extrema, the minimum is -2. Crap, I can't write this morning, -2. Okay, but what are we going to do as far as pre-calc goes? Our global min, well, it's, let's put max out here. It's located at x equals -2. All right, but its value of that global min is -2, and I don't need an equal sign there because they write it. Okay, so that's global maxes mins. I am going to clutter this picture up even more here. Okay, now you also had to do local, right? All your local maxes and mins are in the inside. Okay, so our local max, that 1, 3 would be a local max because it's on the inside of the function and it's the highest point. It would have 2 local mins here and here. All right, because if we remember what in one of the handouts that you were, or in the online notes that you were supposed to download and look at, all right, local was, okay, just considering this portion right here, that's a local min. Just considering a small little section of the graph here, that's a local min. Considering it there, that would be a local max. All right, so now I'm going to pull out another color here and we're going to label. I'm going to color this picture up even more. Okay, so I'm going to label this as global. Okay, I'm going to global max. I'm going to label this one as global min. I'm going to label this one as local max. I'm going to label this one, I'm running out of room to write, local min. And I'm going to label this one also as a local min. So this one gets 2 names. It's a global min, but it's also a local min because it's on the inside. This one is a local max because it's on the inside. All right. This is the global max because it happened to be on an endpoint and literally the highest point in the overall graph. This is a local min because it's on the inside. I'll let you ponder that for a minute. I'm going to change my Zoom window here. So maybe I can change my Zoom window here. I'm going to put y'all on gallery view so I can look at you. All right, I know it's early this morning. How are we doing? Anybody have questions over what I just said?
What would you call the point -4,4?
Actually, it really doesn't have a name because it is an endpoint. All right, it can't be a local maximum because it's not on the inside. So it hangs, it dangles, it's just there. Okay. Good question, actually, though. Very good question. All right, anybody else have questions? This concept, especially in pre-calc here early, I mean, this takes a while. This takes a while to get used to it. All right, in the textbook, you're not always going to have a closed interval. All right, and that's okay. We don't have to have a closed interval. When we do the closed interval, though, I like it because it leads more into calculus. All right, so it kind of prepares us better there. But it just sometimes is harder to understand. Am I still sharing my screen? I am. You're still seeing my piece of paper, right? Okay, so because I opened up my gallery so I could look at all your pretty little faces. All right, let's close that. Okay, so let's do another one. Oh, see when my Sharpie goes through. It's all right. Except it annoys me. I don't know if it annoys you guys. All right, that's better. All right, so let's do it. Let's do another one just real quick here. Not in great detail, but what if I did? Let's do that. I don't know, let's say that's like -5, 2, if randomly making it up. Let's say that's 0, -3. All right, let's see if I can do this one. Okay, so I'm not on a closed interval, and that's okay. All right, for you guys, let's do this pre-calc wise. All right, our global max. All right, doesn't always have to be a value, and it can't necessarily always be located at something. Well, stop and think about what this graph is doing. It's going up forever, never, never, right? Because it's got an arrow on there. So the global max is just positive infinity. Okay, it's not an ordered pair. It's not located at any point in time. We just refer to as global max as infinity. All right, now global min, down arrow, right? Going down forever, never, never. So our global min on this, all right, we're just going to write it as negative infinity, okay, because it goes down forever, never, never. All right, these two are going to be our local, okay, because if I look at just this portion right here or this portion right here, okay, then that's a local max and this is a local min. All right, now it depends. I think at some point in time, I do let you start writing them as ordered pairs. All right, but let's start with, all right, local max. All right, it's going to be located at x equals -5. Okay, the value of that local max is 2. All right, and this definitely is how you got to do your homework answers. I'm pretty sure that like probably in a couple exams, I'm going to let you start doing this as an ordered pair. Okay, I will start letting you do that eventually on our written exams because it leads us more into calc. All right, now this right here, all right, would be a local min. All right, and if you're writing it for your pre-calc homework, you're going to say it's located at x equals 0, has a value, excuse me. Excuse me, I knew I was going to sneeze there. It's going to have a value of my minimum as -3. And again, eventually, all right, I'm going to let you write it as this. Your homework in the book, because it's the way the book is set up, is always going to ask for this. They're going to ask you where is it located and what the value is. All right, so let's go ahead and label this. This is local max, and this is local min. Okay. All right, so again, just kind of like it takes a while to get your head wrapped around this. Actually, so that I don't have to draw another picture and we can speed this up a little bit. All right, I ought to be able to look at this graph right here, and I ought to be able to find some increasing and decreasing intervals, right? I ought to be able to find increasing and decreasing intervals. All right, so let's do our increasing intervals. All right, now, as long as I use the word intervals, then we got to have curly brackets all the time. Intervals, when I use interval notation and I'm identifying intervals on the graph, it's always curvy brackets. All right, always curvy brackets. Now, not for domain and range, but for intervals. All right, so where's this function increasing? All right, I think you watched the video yesterday, right? It's increasing here and it's increasing here, right? Which is, we can locate those on the graph. It's not too bad. All right, they're always curvy brackets and it's x values. All right, it's x values. So what's the farthest x value that the graph attains? Yes, this is going down, but it's also going this way as well because it's at an angle. So the farthest x value that this attains is negative infinity. All right, and then what x value does this come up to? Well, it comes up to the x value of -5. And then there's a jump, all right, because there's another section here. This x value is x equals 0, curvy brackets, all right, and then goes to the right. Yes, it goes up, but it goes to the right, and to the right, positive infinities here, negative infinities here, so I need a positive infinity. So just practicing that as increasing intervals from yesterday. All right, now let's do decreasing intervals, just to make sure we've got it. Again, intervals, interval notation. So all my rules for intervals apply. Always curly brackets, always x values. All right, my only decreasing portion is right in here, okay, which is not hard to find. All right, again, look at the x values. It starts at an x value of -5 and then all the way up until the x value of 0. So it's decreasing from -5 to 0, curly brackets. The increasing and decreasing and constant is not as difficult as the local max and mins that you did yesterday. Okay. Oh, on my online notes, I did show you how to identify the zeros. If on page 3, if you downloaded the notes and looked at them yesterday, I showed you the 2 ways to write it, with the x equals x equals x equals, or with that set notation. So that was in the notes. Okay. Now the testing for even and odd, I don't necessarily think I'm going to do an example of those. The one thing that you